So this is a flow station near a town. A simple stainless steel recorder housing. Inside we have a dual setup here, but we're just going to look at one side of it really. So we've got dual batteries, two batteries. The pump pro system, it's a bubbler system here. That's being recorded on a neon terrestrial or cellular comms logger. It also has a dual system with a Campbell and another harvest modem. So you can see we've got two solar panels, both independent, and a whip aerial for communication purposes. So we're going to have a look around just at what the volts are doing and where and what we can test. So we've got dual power coming in here. One solar panel comes into this regulator. A second solar panel, separated again, comes into this regulator or solar charger at the bottom here. This is a common fuse panel you'll see in many stations. So this runs on automotive fuses of different sizes. So with our volt meter, we're going to plug into a common, the black, and volts for the red this time. We're not using amps at this stage, volts, common, and it sets off. We're going to use the volts. It's going to come up here, so we're measuring DC volts. We can see here we put our terminals across and we're getting 13.37 on that battery. We're getting 14.1. The difference because they're both separate systems at this site, both on separate solar chargers and separate panels up above. Junction box here too. We're getting that same 13.3 across those two terminals. 13.3. These are powering up the modem for the cell phone and the Campbell logger above here. Up here we can see we've got a common negative side and the power side here. Again 13.4 there. 13.4. 13.4. And the solar gain coming in is 20. See here we're reading 20, so 21, nearly 21 volts of power, the sun now hitting the panels through the solar charging controller. It regulates it down to 13.25 or 24 going into our system. So we're going to test the volts here and here, the solar regulator coming in, and check the fuse box here. So you can see this has 1, 2, 3, 4 fuses in, common rail at the back, so we can check that as well and check if any of those are blown or need replaced. Just these clips are holding it, so push those, come off. So we can now test, this is a common rail here, so it doesn't matter where we place our terminal, the lead, and we can test like we go to here, we're getting nothing, no volts registering there. But if we sneak it down the side, here we are, 14.3, 14.3, 14.3, 14.3 across those, so we know all those fuses are fine and working. I'm not going to remove them to test them because it'll pull the power to one of the instruments. So here we have another site and we're going to test the same fuse box. So we have common rail down the back here with our negatives, and we can test the volts across the fuses. So 13, 12.99, 98, 13 volts, 13 volts, 13 volts. And see if we find a fuse with nothing. If we look at it closely, we can see that the fuse is actually blown, it's broken in the middle here. So if we set our meter to continuity test, we can check it here. So it'll beep when it connects a circuit. So now if we test this across the fuse, we'll get nothing. The fuse is blown. If I get a new fuse, so if we take out this fuse, this fuse is okay. The other thing you may have is glass fuses, so small glass fuses like this. Sometimes it's hard to tell if they're broken, so again, continuity test, that one's fine. Now, many sites have two batteries, one is a backup, one is a primary. So if one goes flat, the other one takes over. And these are protected with a diode in between. This is a diode here. And the diode has a it's called a blocking diode because it blocks the current going in one direction, but it allows the current to flow in the other direction. And you can tell it's blocking because one side's got a white or silver end and a ring around it saying it's blocking from that direction, but it's open to flow from the other direction. So if we measure the volts on each side of this, we can see from this primary battery, the backup battery here, 13.22 volts, but on the other side of it, coming in, we can just sneak it in there, 12.98, which is what we were seeing over on the other primary battery. Primary is reading 12.97. The backup battery, or spare battery if you like, is at 13.2. It's reading higher. So this diode is stopping. Unless the current is more, you could be charging it back this way into the backup. But if the primary goes flat, the backup will take over and the 13 volts will start flowing through. So diodes are small things, as you can see here. This is very tiny. And if we hold our voltmeter on one side of it, and we put this on the negative, we put it here, we've got our 12.8 volt. A little bit of voltage is lost going through a diode. That is the downside of a blocking diode, you lose a bit of voltage. So we've got 12.78 flowing through this diode. If I reverse this, so it's now doing its blocking thing, put that back on here, we should get no volts. So there it's reading, it's not reading any volts, just in the millivolts, and nothing's being read there. So nothing's flowing in that direction. Around this way, we're seeing 12.8 volts flowing through. The diode's very handy. Often they could be at the battery side here, or they also could be up at this point here. We just zoom in. We could have a blocking diode between these two systems here. So we could have the primary here with a diode in between the positives, keeping them separated. So check for that, look for that at your sites. Okay, at this site you can see we've got a common negative rail on this side, and here we've got the primary battery and then the backup battery. So they're independent through fuses, but here's the diode in between. So if we look at the voltage on the primary side, we've got 15.47, and on the backup side 14.77. So there's a loss across the diode, but if the primary goes down, the backup will stop. The power won't go back through to a flat battery on the primary side. The backup will keep running. So the meter also has a test for diodes itself. It's got the wee diode symbol, and we just test across it. We'll get no volts, no voltage in one direction, and the other, so 0.5, so half a volt. So that's how much voltage is lost across the diode. So you can test the diode for how efficient it is by just using a meter straight on each end of the diode. So you get nothing in one direction and 0.5 volts in the other. So now we're going to test the current coming into the panel. So to do that, we need to disconnect the power. So the power lead being brown. If it's not red, it's brown. But always check because they could be any colour. Okay, we need to disconnect that circuit. We then change from our volts to our amp, and we set it from we were on volts down to the 10 amp setting to match this, and we'll see what current we get coming in by connecting it in the line. So connecting to this lead back into the circuit. Yep, 0.58 of an amp. And that should be increasing as the sun comes around on the panel. Always remember to connect it up again. And just check those volts again now. Oops, we need to change this back, of course. Yep, 21. And coming out we have 13. And we can also check the voltage coming in here. So this is from the other panel. So I put that around the wrong way, which doesn't matter, you just get a negative number. And we have 16.7 coming in from the other panel, with 14.36 being regulated and sent out to our system. So as well as checking both batteries independently, we want to check fuses and the solar regulators and the power coming in, and every point that you see a power distribution, check you've got volts there. If not, follow it back to where there isn't a volt. It's possibly a fuse that's blown or the battery's gone flat. So it's just a case of being a bit of a detective and finding out what's happening where. This side here doesn't have a diode protection between the two instruments because they're completely separate units, so separate charges, solar regulators rather, separate panels above, separate batteries, so both systems are completely separate. Now if the battery's flat and you need to undo these to remove it, just check that these will possibly still be live and probably coming in from the solar panel and the rest of the system. So never touch these together. Maybe take one off, put some tape around it, take the other off and then back on again, so you keep them completely separated, not touching metal or each other or other batteries. Just be very aware there's always power at all times on these. And before leaving, make sure you put every cover back on, lead back in, check everything before you close the door. So this is a site in the islands where the battery has gone flat due to lack of solar charge. So it was down under 12 volts and the pump pro was struggling here. The fuses were okay, it was just a lack of solar charge and the battery's gone down. And we can look at that voltage also on the pump pro. You can see it was giving us back a reading of 10.8, which is even less volts. And you can see here with the data plot that there's flat lines where the battery's gone flat and the pump pro hasn't operated. And the voltage plot, you can see it dropping off at times, getting quite low. Battery's been replaced, drops off, battery being replaced. So just not enough solar charge for this site, so that needs a better panel.